Welcome to today's session. Today we will be discussing about how to delete a node from an AVL tree. So before we start discussing about how to delete a node from an AVL tree, we will see the basic scenario to delete a node from a binary search tree. Let's consider this tree as an example, and we are going to see there are three scenarios to delete a node from a binary search tree. So later on we will balance the tree and make the tree as an AVL tree. Okay, so all the deletion, either a deletion in a red black tree or a 2 to 3 tree or a binary tree, it's going to follow the same principle. Okay, there are three cases to delete a node from a binary search tree. After you deleting a node, you have to check whether the tree is balanced to check whether it is an AVL tree. If it is a red-black tree, you have to check whether it is a red-black tree. So after deleting a node, you have to check whether it is a red-black tree. So in all the types of tree, the deletion follows the same principle, which is same as binary search tree. Okay, now let's consider three scenarios here. First, let's consider the first node. Suppose you want to delete the node 8. Okay, node 8 is not having any childrens. Okay, so it is always straightforward to delete a node which is not having childrens. So directly you can delete the node without any replacement. So here I want to delete node 8. So just I will go and then delete node 8. Okay. Suppose you want to delete node 7. This is scenario 2. In node 7, it has only one children. So if it has two children, then you will have a confusion whether to replace node 7 with a left child or a right child. But node 7 has only one child. So here there is no confusion. So definitely you're going to delete node 7 and replace it with the left child. So node 7 will be replaced with the left child. Okay, so this is the second scenario. So first scenario, there is no children, so direct delete. Second scenario, there is only one child. If there is only one child, either left child or right child, replace that node with either one child, left child or right child, if there is only one child. The next scenario, here you want to delete, so node 4 will be replaced here. Suppose you want to delete 11. So now if you want to delete 11, there are two possibilities because it has two children. Left child and the right child. So in that case, you will replace 7 with either the predecessor or the successor. Okay, so predecessor, what is predecessor? Either you will replace it with predecessor or you will replace it with successor. Okay, so predecessor is the largest node in the left subtree. So what is a predecessor? It is the largest node in left subtree. Okay, what is a successor? Smallest node in right subtree. Okay, so here if you take the left subtree, which is largest node, there is only one node in the left subtree, right? These are deleted, so you have only one node. So definitely if you want to delete 11, you have to replace it with 4 only. So there are two possible solutions for this one. So either you will replace 11 with 4, or you can take the successor. Successor means what? The smallest node in the right subtree. So which is the smallest node in the right subtree? It is 12. So either you will replace 11 with 4 or you will replace 11 with 12. So there are two possible solutions for this. So replace the node with two childrens with either the predecessor or with the successor. Predecessor means the largest node in the left subtree and successor means the smallest node in the right subtree. So 11 will be replaced with 4 or 11 will be replaced with 12. Okay, so when you want to replace 12, then 12 will be replaced with 13 because 12 has only one child, right? So directly replace 12 with 13. So here you will have 13, okay, and the 11 will be replaced by 12. So there are two possible answers. So I will put a slash here, okay? So either replace 11 with 4 or replace 11 with 12. So this is the three scenario for deletion in binary search tree. So it's very easy. If there is no children, direct delete. If there is only one child, replace that node with that one child. If there are two children, replace the node, deleted node with either the successor or with the predecessor. Okay, so this is a principle. Suppose they ask you to delete the node from an AVL tree. Then for every deletion, you have to check the balance factor of the tree. Okay, so let's take the same example. Let's take the same example and let's see how to delete from the AVL tree. Okay, so here you have 11, here you have 19, here you have 7, here you have 12, Okay, so just we have to check the balance factor of the tree after every deletion. That is the only difference. Sorry, this will be 16 and this will be 20 and this will be 60. Okay, now let's delete 8. Okay, so if you delete 8, you know it's direct delete. Okay, so just I'm deleting 8. Now check the balance factor. So this will be 0. This will be the height of this minus the height of left minus height of right. So height of left is 1 minus 0. So this will be 1. So this will be 2 minus 2. This will be 0. Okay, so this will be 0. This will be 0 minus 1. This will be minus 1. Okay, so this will be 3, the height of the tree. 1, 2, 3. 3 minus 1, 2, 3. So this will be 0. Okay, so this will be minus 1. Hope you know to calculate the balance factor of the AVL tree. If you have a doubt, I have already put one video on AVL tree. So kindly go through that video to check how to calculate the balance factor in the AVL tree. So this will be 0. This will be 2 minus 2. This will be 0. So you can see all the tree is balanced. Okay, so in AVL tree, the balance factor will be achieved if it is 0 or 1 or minus 1. If it is greater than that, then the tree is not balanced. If the tree is not balanced, then you have to do the rotation. Okay, the next node that you want to delete is you have to delete node 7, right? So if you want to delete node 7, so if you want to delete node 7, now here you can see 7 has only one child. Okay, so there is no confusion. Replace 7 with 4. So I will going to replace 7 with 4. Okay, we'll replace 7 with 4. Now again calculate the balance factor. After every delete you have to calculate the balance factor. So balance factor will be affected only in the left part of the tree because you did not touch the right part. So here alone I will calculate. So this will be 0. Okay, this will be 0. So this will be 1 minus 2. So this will be minus 1. Okay, and this will be 2 minus 3. So this will be 1. Sorry, 2 minus 3. This will be minus 1. Okay, so this will be minus 1. Okay, so this is after deleting 7. Next you have to delete 11. Okay, if I want to delete 11, then I told you there is two possible solutions. You can replace 11 with 4 or you can replace 11 with 12, right? So let us replace 11 with 4. Okay, so now 4 will be deleted and then I'm going to replace 11 with, and then this balance factor will be affected, right? So I have to calculate the balance factor again. So I will replace 11 with 4. Okay, now calculate the balance factor. So this will be 0, this will be minus 1, this will be minus 2. Okay, so here you can see the balance factor of the tree is affected. So take these 3 nodes. Okay, so let me draw this node separately. So you have 4, 12 and then 13. So here you can see this tree is heavy on the right side. So what you have to do, you have to do a left rotate. You have to do a left rotate. So finally what will happen? This 4 will come down. Okay, so attach here. So now let me attach this part. So this part will change now, right? So I'll erase this and replace with this one. Okay, so this part will become like this. 12 on top, 4 will come down and then 13 will come here. Now calculate the balance factor. The right side is not affected, so you can leave as it is. So this will be 0. This will be 1 minus 1. So this will be 0. 2 minus 3. This will be minus 1. So the tree is balanced now. Okay, the next node that you want to delete is 14. Yeah, so you want to delete 14. So if you want to delete 14, now you have to replace it with either successor or the predecessor. So predecessor, let's take the largest node from the left subtree. So this is your left subtree, right? So which is the largest node from the left subtree? 13 is the largest node from the left subtree. So I'm going to replace 14 with 13. Okay. Okay. So I'm going to replace 13 there. Okay. So this will be 13. Now again calculate the balance. So this will be 0. This will be 1 minus 0, 1. This will be 2 minus 3. That will be minus 1. The tree is balanced again. The next one we want to delete is 17. So we want to delete 17. 17 has only one child. So directly replace 17 with 16. Right? So here it will be 16. Okay, so I'm going to delete the balance factor because I want to calculate again. So I'll replace this with 16. Okay, so we deleted 17, so it will be replaced with 16 because it has only one child. Now calculate the balance factor. So this will be 0, this will be 1 minus 0. This will be 0, this will be 0, 0, this will be 0 again, this will be 1 minus 2, so this will be minus 1, this will be 2 minus 1, 2, 3, so this will be minus 1. The tree is balanced, so no need to rotate. So after every deletion you have to check whether the tree is balanced or not. If the tree is not balanced, take the 3 nodes which is not balanced. Suppose for example you deleted a node this side. Okay, suppose you deleted a node this side and the balance factor affected here. Suppose this become minus 2. Okay, then you have to select these 3 nodes. Okay, so because you deleted from this branch, right, don't select these 3 nodes. Okay, so from which branch you deleted, you select that branch and then rotate, make the rotation. So here you can see this is right left, so it means you have to do 2 rotations, right? So first you have to do a left rotate, then you have to do a first you have to do a right rotate, then you have to do a left rotate. So in this case, right? So if you have any doubts regarding the rotations, please kindly watch the AVL rotation video for more information. So with this, I think we covered all the 3 possible cases for deletion, and I also told you how to delete from an AVL tree. After every deletion, check the balance factor. If it is a red-black tree deletion, after every deletion, check whether it satisfies a red-black tree condition. Okay, hope you understood this concept. Thank you for listening.